Normally propeller blades are made out of plastic or carbon fibers, and there are different materials. But the major of the propeller blades used for drones are imported from outside India. So I wanted to make this propeller out of composite materials. Composite material are the material in which 2 or 3 materials are binded together such that it gives properties which are better than the parent material. Similarly, for carbon fibers are the thin strands of fibers made out of 99% carbon, and they are binded together using resin. What I thought was that, what if I could take the cotton handkerchief which we use and then use Feviquick or cyanoacrylate to bond it together. Normally, if you have noticed that when Feviquick accidentally pours on your cloth, it gets hardened. Similarly, so we were going to use that property to make the at the end of the video we will explain that why the method failed and what are the ways to improve these methods. So first I will apply sellotape to the pipe. So this will help to take the blade out of this mold. And second, what I will do is to mark where I have put the sellotape and all. So I will cut a portion of this type of handkerchief. This is a cotton type handkerchief. So I'll just cut a portion of it and paste it on, and then I will take the propeller from the drone and will mark the shape of it on the handkerchief such that I will pour the cyanoacrylate on that portion only and cut out the blade from the handkerchief. So right now I'll be applying this cyanoacrylate or Feviquick to it to make it firm. Then I will leave it for drying. After it gets hardened up, apply a second coat of Feviquick. And let it dry. We will take out the blade from the pipe and cut its edges using a scissor. So like that we have 2 blades for our propeller. The weight of the original blade is 0.63 grams. The weight of the home built blade is 0.36 grams. To make the blade firm, we'll be using Araldite. Araldite will make the blade strong. It is 1 part hardener and 1 part resin. And we'll mix it and we'll use it on the blade. After applying the Araldite resin to the blade, we'll cover it with a plastic and we'll leave it for 12 hours to dry. Finally, we'll take out the blades and drill it such that it can be attached with the helicopter. Here we have the helicopter with a home-built blade, and it is sort of working. In upcoming time, we'll actually check the parameter of the blade and its performance. The blades are strong, it is not getting out of its attachment, which is a very good sign. The helicopter is actually hovering, but it is not flying, and we'll investigate about the problem, why it is happening so. Because of the weight difference between the 2 pair of propellers, the homemade and the pre-made propeller, the helicopter is unbalanced. So this is a stage which I have prepared. So around 10 grams of thrust being produced approximately, but it is not enough to lift the helicopter. If we put the original blades to the helicopter, it is flying alright. This is a slow motion video in which we can see the blades are actually deforming, turning flat and producing less thrust, and also the blades are wobbly because of the weight difference. If the original blades of the helicopter are attached, it is working perfectly fine, and its angle of the blades, and it is also not wobbly. So balancing the weight of the blades is a crucial issue. Also, we need to make the blades firm. As you can see from the video, we have made different types of propellers. Here, this, and there are many more. So what happens, you can see in the slow motion video also. So this thing is called the angle of the blade. So what happens in the propeller is that when the propeller moves, actually it pushes the air downward. Now, as the angle of the blade is more, it can push more air. But if the angle of the blade is flat, it will push less air. So what problem which I was having is that while my propellers were moving, so it would actually get flattened. So that was actually, let me magnify it, this flatness was the problem. Because it was getting flat, because of the drag of the air, it could push less air downward. Hence the helicopter or the drone was not flying. Let me explain one better way. So for example, if it is moving like this, at a certain speed, this blades would actually become like this. It would actually flat out, and because it used to get flattened, hence it can move less air downward, and this was one of the problem. Second problem was that my propeller blades were not uniform weight. You could see the weight from the display of the weight machine. Two blades were of different weight, and because of this different weight issue, because the weight of the propellers was different, the helicopter was wobbly and it could not efficiently push the air downward. So in the future projects, what we will do is that we'll try to make the propellers which will have equal weight, and moreover we'll actually improve on this composite material technique such that our blades does not bend while it is in air. So this bending doesn't happen. So these are the two improvements which we need to make. And thirdly, by seeing the YouTube, I have seen many YouTube channels about DIY propellers, and from that actually I got the inspiration. We take this PVC material. So these are the PVC pipe which are used for electrical wiring. So by cutting this PVC pipe, we can get this type of propeller blades. And these are very much firm, but one of the disadvantages is that it has a weight. So we'll be also seeing how to use this PVC pipe and how to melt this type of plastics to make the blade which we want, and larger blade for larger drones. So this is for the propeller video second version. So hope you have enjoyed, and if you like the video, if you like this effort, please subscribe, share and like with your friends. Thank you. See you in the next video.